Good morning, respected students. Okay, that means dear students. As a continuation of yesterday's class, yesterday I have given you the snaps of the experimental curves. So here it is with me. Actually, these graphs are given during exam. Okay, so just I will briefly explain. Just it will take only few minutes. So first you can see this is a graph, okay, but because it has a twist, and here PS, that means point of stimulus, it is written point of stimulus. When there is a point of stimulus and point of contraction, then you will know that it is a myogram. Okay, so what you have to, if you get this graph, then what you have to say? So this is a myogram of Frogs gastrocnemius sciatic nerve muscle preparation, showing the effect of temperature on muscle contraction. Here, because it is 10 degree, 26 degree, 38 degree, it is written here. So in this context, sorry, and below is the time tracing. Time tracing is done by 100 hertz tuning fork. Okay, so that one wavelength will be 0.01 second. Just like you can calculate the point of that latent period and everything, but let us forget that one. So if you get this curve, then you have to simply say this is a myogram showing myograms of Frogs gastrocnemius sciatic nerve muscle preparation, showing the effect of temperature on amphibian muscle contraction. Okay, then the second this curve is here, multiple curves here, 1 2 3 4 5 6 sorry. So here it is written, it may not be clearly visible because it is a xeroscopy, effect of single stimulus. Then it is written second stimulus in the first half of the latent period, then second stimulus in the second half of the latent period, just like that. And here it is there is also point of stimulus and point of contractions. This type of simple twists are some muscle contractions. Okay, so many stimuli are given at many different times. When I explain the circuits and instrument, so in the Sherrington-Starling's dam kymograph, there was a striker. And if you remember, the striker has two blocks, okay, for two successive stimulus. When the blocks will be together, only one stimulus will be there. So I am not going to details about that. You know it. And first of all, one more thing I want to say. This video I have made for my students only. Okay. So if it is not interested for any other people, so please ignore it and don't watch it. Okay, and the students who thinks it to be beneficial, then I'll be very glad and you like it and you give comment so that I can improve myself day by day. Okay, so let us go to this graph. So this is a myograph. Sorry, this is a myogram showing effect of two successive stimuli on Frogs gastrocnemius sciatic nerve muscle preparation. Then what will happen when the stimuli will fall? So first, when the stimuli will given at quick successions, so within the latent period, then what will happen? Then when the latent period is over, that early part of contraction, then what will happen? That you know. So if you get this graph, it is that myograph. Number 3, here you can see there is a V curve, and one is M curve. So here V represents vertebra and M represents muscular. That means two stimuli are given here. one keeping the electrode, say suppose this is the nerve, suppose, and this is the muscle. That means one electrode was placed. First stimuli was given by placing the electrode over the vertebral end, and second stimuli was given placing the electrode over the muscular end. Okay, so there are two twists. That is, one is M curve or one is V curve. So how you have to say, this is a velocity curve. Okay, so you have to tell that this is a myogram of Frogg's gastrocnemius sciatic nerve muscle preparation, showing measuring the velocity of nerve impulse. Then how you will measure the velocity of nerve impulse? Because you can calculate the length of the nerve. Okay, that means from vertebral end to the muscular end, the length of the nerve you can calculate. Suppose it is, say, x centimeter. So then you just there is a latent period of the V curve and latent period of M curve. Definitely the impulse from vertebral end to reach the muscle, it will take time. So latent period in case of when the electrodes was at the vertebral end, it will be more. So latent period of vertebral end minus the latent period of muscular end, it will give the time required to travel this x centimeter of this nerve fiber by the impulse. So you divide length by the time, then you will get the velocity of nerve impulse. And okay, let's jump quickly. So you see, so here I have already told there are two type of lever when you trace heart contraction of heart. That is the frog's heart. I should have shown it. Yeah, there is a probably frog in my garage, and if I can catch him, then definitely I will show how to dissect it, how to pierce the heart. That definitely I will show you. Okay. So you see the contractions are like this. Okay, so this is the ventricular systole, this is the atrial systole. Atrial systole is it coincides with the left part of the ventricular diastole. So there is a notch. This notch is because of pulling of the this atrioventricular valve towards the ventricle. Okay, that you know it. So if you get this curve, here it is written the normal cardiogram of frog. So it is easy. A due to the contraction of auricle, B due to the contraction of ventricle, C due to the relaxation diastole of the heart. So it is clear, okay, because there is no ion is written, no temperature is written, nothing is written, no extra stimulus is given. So this is a simple cardiogram. So how we have to explain? So this is a cardiogram of frog's beating heart, showing the normal tracing, and the electrode used here is the lever used here is a Starling's lever. I have already explained you, when you use Starling's lever, the heart is connected downward. So any ventricular systole or any systole, any contraction of the heart, it will pull the pointer downward. So downwards are the contraction, and it is okay. Let me see. Oh, sorry. Here contraction is in the upper part. So definitely this is by a simple lever. So these so small waves. Okay, so I don't know whether you can see or not, but here under this picture it is written surface actions of various ions. actions of various ions on frogs beating heart. Here sodium chloride, potassium chloride, adrenaline, acetylcholine, and calcium chloride. All things are written here. So now you know this is a cardiogram of frogs beating heart, showing the effect of cardiac contraction while we use different ions. Say sodium, if we give excess sodium, then what will happen? If we give potassium, so here you remember one thing, hyperkalemia, potassium is dangerous because potassium will arrest the heart in contraction. Okay, so next go to the another curve. So here it is also same. Here it is written, oh no, there are two graphs. This is given. This is also effect of ions. Okay, in this one particularly, this one is usually given in exam. So here you see, you can, if point of stimulus is there, so point of contraction is there, so definitely these are muscle twist, that is muscular contraction of what muscle? Frogs gastrocnemius muscle. And what is the preparation? Frogs gastrocnemius nerve muscle preparation. So you will see here CR, contraction remainder. This CR will give you the clue. That means, yes, it is showing the phenomena of fatigue. When you repeatedly give stimulus to a muscle, then ultimately there a points come when the muscle cannot contract anymore. Okay, not only this, just before that when the muscle cannot contract, just before that, muscle will not be able to totally relax also. Okay, so because relaxation is also a active phenomena. Okay, so when, if you remember this actin and myosin, one ATP is always converted to GDP just to get relaxed. Okay, so those you know. So how you have to explain this graph? So this is a what? Myogram of frogs gastrocnemius sciatic nerve muscle preparation, showing effect or of simultaneous stimulus, or say showing the effect of fatigue. Okay, so how fatigue set up? So there is a you can prove it whether it is in the muscular end, whether it is the nerve end, or where the fatigue occurs. You can prove it. So if you directly stimulus the muscle, then it will contract. Here the third figure is the when stimuli is given to the muscle directly, then the muscle will contract. Okay, and there is a preparation called Rio-base preparation. Okay, Rio-base preparation. Here what is done? Say this is the, say, vertebral end of the nerve, and say this is the muscles, sciatic muscle. It look like a silly, no? Forget it. So you have given repeated stimulus one after another, and the muscle has fatigue has been set up. Okay, then at that time, when you give stimulus to the muscle directly, then the muscle will contract. That means muscle has not become fatigue. Then what we will do? We will use the nerve. So another fresh preparations of frogs gastrocnemius sciatic nerve muscle preparation will bring, and that nerve we will attach here. This is the other muscles. Then we will give stimuli over this second nerve of the nerve muscle preparation. Then you will see this muscle will contract. Okay, so here by this you can prove that this contraction, neither nerve become fatigue, neither the muscle become fatigue. Okay, so it is the depletion of the neurotransmitter, and it takes few time. If you give Ringer's solutions and wait say about 10 minutes, and definitely the muscle will regain the energy, then there will be neurotransmitter productions and it will again contract. So here this small house, mountain like structures 1 2 3 4 5 6, and beneath this it is given that 8 stimulus per second, 10 stimulus per second, 13, 20, 35, like that. That means in quick succession different number of stimuli is given to a muscle. So this is what Titenas curve. Okay, so you have to say, so this is a myogram of Frogs gastrocnemius sciatic nerve muscle preparation, where stimulus of different frequency is given, and ultimately to show the effect of the formation of tetanus or effect of tetanus. And before tetanus there is a staircase phenomena. Just in enteric fever, pyrexia is called step ladder pyrexia. Okay, it just go up and up and up and up and up, and when it come down, it just comes down and down and down and down and down. So like that, this is contraction. After the previous contraction, second contraction muscle will be less relaxed and it will go high up, high up. So that is the staircase phenomena. You read what is the cause of it. So again, this, when you see graph like that, so these are the muscle contraction. Always remember, this is the ventricular systole, this is the atrial systole, and this is totally the diastole, and there is a notch. Sorry. And again, this is also by using a simple electrode, because simple electrode always pulls the electrode high up, and positive deflection will be the contraction. If this same graph, if we would have traced in using a Starling's heart lever, then the contraction would have been like this. It's okay. This systole, another systole, systole, another systole, like that. Because so short time, I have to prepare the video, otherwise the memory will be high up. That's why. Any doubt, you give comment or you can WhatsApp me, then definitely I will try to answer. So here what is given, relaxation diastole, it's a normal cardiogram of the frog. Again, previously it was given. Again, there is one more. Okay, two are remaining. So one, your Dr. Rimpi, she took probably this Stenius ligature, and one is the vagal escape. Okay, and I have given you two questions, and one was why the denervated heart rate is more. Okay, in case of heart, it has both sympathetic and parasympathetic supply, and usually the parasympathetic tone is higher in heart than the sympathetic tone. So what is the rhythmicity of SA node? Suppose it is say about 80 to 100. Okay, just approximately 80 to 100 contractions or stimulus per second. Then if you cut the vagus nerve, heart will beat at the rate of 80 to 100. But because of the intact vagus nerve, it always inhibit the contractions, then rate of contraction. Then, so say in case of an SA node is working, so heartbeat will be a bit lower than 80 to 100, say about 70 to 80, like that. Okay, so in heart, because of the vagal dominance or parasympathetic dominance, the denervated heart rate is more. Okay, you got it? So here what we will do, say this second, this first curve, here it is written vagal stimulus. So you know these are the muscle contractions. Sorry, these are the heart contractions. So this is a cardiogram. So this is the cardiogram of frog's beating heart. Definitely we do it on frog's beating heart, showing the phenomena of vagal escape. That means, suppose here you have given the vagus nerve, you have to identify. How to identify? Because there is no dissection is not shown, so it is very difficult. So roughly I want to show you. This is just a frog, which this is that wider W. Okay, and so these are the frog's legs. Okay, don't laugh at my diagram. My diagram are very poor. So suppose here is the beating heart, and you know frog's heart is having 3 chamber only. So by the side of this, if you just dissect, then you will get the vagus nerve, white structure, that is the vagus nerve. Okay, and when we were student, PG students, then what our teacher told, that give stimulus, record the heart rate and give stimulus to every structure whatever is. Okay, that should not be done, but to say and to do, it is there are lots of differences there. Okay, so somehow you have to identify the vagus nerve, then you just put the lever and let the rotating drum rotate, then you trace the contraction, then with an electrode you stimulate the vagus nerve. Then what will happen after vagal stimulus? Definitely it will depend upon the intensity of the stimulus. If the intensity is so high, okay, suppose say contraction was like this much intensity, which normally is supposed to be say here like this. So in that case, after stimulation of the vagus nerve, there may not be totally pause. There may be some smaller contractions. Okay, and this right heart, this right how many vagus nerve is there in our body? Okay, you read it. So here you have given the vagal stimulus. Then ultimately what will happen? The sympathetic stimulus will try to overcome it. Okay, there is an matter and antimatter, sympathetic and parasympathetic. So when the sympathetic stimuli will sympathetic activity will take the upper hand, then again the heart will start beating. So that is called the vagus escape, nothing else. Okay, so you have to describe it. Say this is a cardiogram of frog's heart, showing the effect of vagal stimulation on it. Okay, and lastly, this is the sorry, this is the graph of Stenius ligature. So Stenius ligature, there should not be any confusion. It is, everyone says this is very tough, very tough. I think this is the easiest one. Okay, just use a human heart. Compare the frog's heart with human heart. So if it is the human heart, so this is the right atrium, and here in the right atrium only, both the atria, SA node and AV nodes are present in the right atrium only, not in the left atrium. Okay, so what will happen if you ligate here? Definitely, ligation means it will be a complete, say, block, sinoatrial block. This from SA node to AV node, there will be a complete block. Then the dominant pacemaker will be the AV node. So what will happen if you put here ligature? Say first heart was beating like this. So now, because you have cut off the connection between SA node and AV node, so the AV node will initially there may be a pause. because one bomb has blasted, so no one know what to do. Okay, then someone told the AV node that, hey, now you are the boss, you take the upper hand. Okay, then the AV node will come into play, but because its rate of auto-rhythmicity is less than that of SA node, so it will start contraction, but rate of the contraction and the force of the contraction will be somewhat compromised, lower. Then if we give a ligature here, say between AV node, then the main bundle branches which takes the action potential to the ventricle. Then what will happen? Say this AV nodal stimulus will also be unable to reach the ventricular musculatures. Then what will happen? Again there is a chaos. Say there will be a pause. Now this time pause will be a longer one. Then after that, that everyone will say that the ventricle, you are the only option, you take the upper hand. Then the ventricular musculature will start producing stimulus. Okay, then but rate will be less and force of contraction will be minimum. Okay, this is also called idioventricular rhythm. Okay, so hope you guys you have understood. There may be a mistake because today like this I am making the first video, and subsequently I will try to improve myself. And lastly, again I want to say to all the audiences, all the viewers, that this channel actually, necessity is the mother of invention. When during online classes it was very difficult to upload classes, during that time only I thought that we can upload like this, and like that the channel is formed. There is no other intention, and I may be wrong, so please point me out so that I can correct myself. Okay, and if you think it may help you, I will take out different topics, different MCQs. Like I always cover my tutorial group, and definitely I will cover for everyone. And any doubt you write in comment section, definitely I will try to answer, and I will try my level best, to the best of my knowledge, to explain it. Okay, thank you very much. Have a nice day.